In this lesson, we're going to re-examine rotational trigonometry, what I like to refer to as Sir-Sixtertics, but we're going to do it in terms of radians this time instead of degrees. So the content itself is actually all review stuff. The difference is that we're measuring our angle now. So rotational trigonometry, as we said, is used for we're going round and round in a circle, which is the perfect use of Sir-Sixtertics. That's what we do. Some reminders of some things. Your initial arm is where you start, in other words, where your arc length is being measured from. Your terminal arm is where you end. Your angle in the middle is your central angle. We did all this last year, or last course, in finding our angles or finding our ratios. We're going to do the same thing. We're just measuring that in a different way. Okay? I'm hoping you remember your different ratios. Your Sir-Sixtertics comes from the primary ratios, Sir-Sixtertics, all the first letters, right? Your reciprocal ratios, cosecant, secant, cotangent, are the opposites. Okay, we're just flipping them over. So S goes with C, C goes with S, and tan goes with cotan, of course. Okay. Don't forget we have this relationship for circles. If I need X or Y or R, I can use the idea of a circle. A formula for a circle is X squared plus Y squared is R squared. Okay, so let's talk about the 6 ratios for a terminal arm that rotates to -3 and 7, and use one of the ratios to determine the principal angle in radians. So what does that mean? I have one that started at 0 radians, and rotated around to -3 and 7 up here. So I had a circle that did this, not exactly a circle, but that idea. And there's my terminal arm. I started at 0, I rotated counterclockwise, and I had a central angle. How do I measure that central angle? Well, as you remember from last unit, or last course, there's your y value, there's your x value, and I can use x squared plus y squared to equal r squared to find my r value. R will be root 50. Oh, sorry, root 58. That's not 50. 49 and 9. Root 58. Okay, what are our ratios? So our regular ratios, our primary ones, are sine of our angle, y, over r, root 58. And you might remember we have to rationalize when we have root signs on the bottom. So we multiply by the root we want to get rid of. And that will give us 7 root 58 over 58. And our cos ratio, it's x. X value is -3 over root 58. Do the same thing by rationalizing. The only thing that's going to change is the number out front. And then we got our tan ratio. Tan is y over x, which is 7 over -3, or -7 over 3. Okay, we can also find our reciprocals. So sine, not sine. Reciprocal of sine is cosecant. I can go back to the initial answer for this, right? I want to flip this. That way I don't have to re-rationalize again. So 58 over 7. We can do secant, opposite of cos. So root 58 over -3. And then we have cotangent, the opposite of tan. Tan was 7 over -3, so we have -3 over 7. It's exactly what we did last unit. We actually haven't changed anything even yet. We're just writing down our ratios. And the second part of this question says, use one of the primary ratios to determine the principal angle in radians. I have to use principal angles because my calculator is not programmed for non-principal angles. It's only programmed for primary ones. So I'm going to pick any one of these 3. Now, my suggestion is let's pick the easy one. That kind of looks like the easy one, right? So if I want to find an angle, and I've got a ratio, I'm just going to write down here, tan theta equals 7 over -3. And I want to find an angle, we can use the inverse using our calculators. The only trick is today, I have to turn my calculator into radians. There's a button, a DRG button, or under your mode, where you have to change degrees to radians. Use that, so your calculator is in the right format. And you should get 1.16 radians. Now, if you forgot to change it and you left your calculator in degrees, you could convert your final answer in degrees to radians by using your pi over 180 formula. Right? But that's a lot of work. You might recall when you use your calculator, it always finds us the acute angle. The angle inside the triangle. So some people's calculators will give them the answer we have down here, 1.16. Other people's calculators might not. So my suggestion is when I'm using a calculator, I'm going to ignore the sign. Okay? If I ignore the sign, I know for sure it's finding me this angle. It depends on your calculator if it finds that one or not. That's why it's just a better rule. Ignore the sign, find the acute angle, and then use your ideas of rotation trigonometry to find the actual center angle that we want. The center angle we want would be, well, from here all the way around to there is pi, right? Half a circle. So our answer is going to be pi minus 1.16, the radian measure we had inside the triangle. And that's going to give us a center angle of 1.98 radians. Now try a calculator. Maybe some of you got that when you had the negative sign in there. It depends. Some calculators like that, some calculators don't. For the rest of these things, will always ignore the sign. That way I know I have the acute one, and I just have to analyze my picture. Do I want the acute, or do I want the one on the opposite, the complementary angle? Okay? Okay, let's take a look at some special triangles. So in our previous course, we examined how we could find the exact measures, ratios, of angles without using our calculator. For example, sine 60, cos 120, things like that. Well, we want to apply those same ideas, but in radians. So we got to take our special triangles, the 30, 45, and 60 ones, and change them. And so our new special triangles, we'll start with the nice one, the 45, 90, 45 one. We'll have our same side lengths, 1, 1, and root 2. And we used to have 45s. Okay? But if we take that 45 and we do our pi over 180 bit to change it to radians, that comes out to pi over 4. Okay? So this is going to be our new triangle, this one here, okay, in radians. Same side lengths, but our angles are now pi's over 4, quarter pi's. And if you think about it, if this was 0 and this is pi, I could divide this into 4 equal quadrants, 1, 2, 3, 4. It makes sense that if these are 45 degrees, which they are, right, it's half of 90, then each of them should be pi over 4. They're all 45s. Okay, so that's the easy one to remember. The trickier one, the 30, 60, 90, same ideas. We're going to transfer that. So 30 is going to become a pi over 6, and 60 is going to become pi over 3. Here our side lengths, we have a 1, a 2, and a root 3. In the previous thing, we always said root 3 and 30 beside each other, the 3's by the 3's. Now the 3's are opposite one another. Okay, so if you know where root 3 is, across from it will be pi over 3, or vice versa. Okay, let's give some of these a try. So we're going to find the exact value of tan of pi over 6 using Sir Sixterticks and our ratios and all that good stuff. So the first thing I need to do is draw it out. Okay, if this is 0 and this is pi, right, half of it 180, and pi over 6 really means I need to divide this into 6 equal parts. Right, 6 equal parts. Right. I want just 1 pi over 6, which means the angle right here is pi over 6. Okay, reminder, we should always make our triangle with the x-axis. Pi over 6 is there. That means the other one has to be a pi over 3. We just said root 3 is always across from 30. We should always have a 2 and a 1 in there. Here's my diagram. Now, I'm not always going to draw all 6 parts in. I want us to stop and think about it, but I want you guys to think about how we could divide our quadrants into the parts. The pi's over 3's, or the pi over 4, or the pi over 6. It's really just breaking each half of the circle into various segments. Sir Sixterticks tells us what our ratio should be. We want tan, so we want y over x, which in our case is 1 over root 3. It's got a radical in the bottom, so we're going to rationalize There's our exact answer for tan of pi over 6. Okay, so we no longer need degrees if we use our processes, but our new special triangles are in radians. Okay, let's try a new one. Secant, negative 2 pi over 3. Okay, so negatives, you might remember, work backwards. Okay, so if there's 0, I'm going to go clockwise. I want the negative direction. Okay, I want to go 2 pi over 3. Well, if I think of this as breaking into thirds, again, here's pi. This will be 1/3, 2/3, 3/3 is 1, 2, 3 of them. 2 pi over 3 is that far back. Okay, I want to make my triangle with the x-axis. There's my triangle. If this is 2 pi over 3, what's inside the triangle? I need the third pi over 3, right, to make a whole pi. Pi over 3 is across from root 3, and it's going down, so it's negative. Makes this a pi over 6, which makes this one a 1. And then we need our 2. The 1 will be negative because we've gone to the left. Left or down are always negative signs. Okay, we need secant. Secant is the opposite of Sir-Sixer because it's the opposite of cos, reciprocal. So our answer, instead of being x over r, will be r over x. If we simplify that, we get negative 2. Okay, let's try some more. Cos, 3 pi over 4. Cos 3 pi over 4. What do we got for that? Well, pi over 4 is that one. That's 1 and 2. 3 and 4. I want to go to 3 pi over 4. That's that big. Which means what's left inside? The fourth pi over 4 to make a whole pi, right? Pi over 4 makes this a pi over 4. And we know these are special triangles 1, 1, and root 2. Left is a negative. Cos is x over r. So negative 1 over root 2, or rationalized negative root 2 over 2. And cosecant 11 pi over 6. Okay, 11 pi over 6. So if I'm thinking about that, I'm thinking about the fact that that's more than a pi. It's more than 6 over 6. But it's not quite 2 pi. Because if it was 2 pi, that's 0. That's half a pi. That's a whole pi. That's 3.5 pi's. Oops, 3 half pi. 2 pi would be back here, right? Back the whole way around the circle. I'm almost there. In fact, I'm just a little bit short of that by pi over 6. If that's pi over 6, that makes this pi over 3. Across from the 3 is a root 3. 2 on a hypotenuse. Down 1. Cosecant is the opposite of sine. Sine is y over r. So r's will be r over y. There's our answer. Okay, so we can find exact values the exact same way we did in previous. Just got to think about our diagrams a little bit more to think about where we're going to draw those. A couple of tricky ones sometimes cause some confusion. Okay, tan of pi. Well, where is pi? Pi is right here. Now, this is a tricky one because it's not on, and it's not a triangle. It's on an axis. But we learned a trick last year about the fact that, let's think about our circle. The easiest possible circle is a radius of 1, which would make the location of this point negative 1 and 0. It's 1 unit along the x-axis. Well, that's an x, a y, and an r. I can do tan pi. Tan is y over x. There's my answer. The tan of pi is 0. And how about cos 20 pi over 8? Well, 20 pi over 8 is a big number. Ooh. Maybe I can reduce that, make that easier to work with. If I divide them both by 4, I get 5 pi over 4. So it's more than a pi. I'm going to go past pi by a quarter, a little bit past pi. Oh, sorry, I didn't divide that right. That's not 5 pi over 4. It's 5 pi over 2. Okay, let's think about that. What is that? That's like 5 pi over 2 is, it's like saying 2 pi plus a pi over 2, right? 2.5 pi? So I've gone all the way around, whole 2 pi, and then I could go another half a pi. There's my triangle. That's pi over 2. The whole thing is 5 pi over 2, but that extra bit's pi over 2. That's not where I'm drawing that right. Sorry, guys. Pi over 2 is not there. This is pi. This is pi over 2 up here. So I've gone all the way around and ended up back here again. Again, on the circle. But if I think about a circle of radius 1, that point is 0 and 1. X and y. Cos is x over r, so 0 over 1, or 0. And so those special ones that line on the axes, just find the coordinates. Make R1 the easiest possible circle, and then use your Sir-Sixer-Tix. Okay. We can also work backwards. You might remember the cast rule. The cast rule tells us where different ratios are positive. So the cos ratio is positive in this quadrant, as is secant. They're all positive in that quadrant. Sine is positive, as is cosecant. And tangent is positive, and so is cotangent. Okay, so most answers will have 2 different possibilities because we don't know which quadrant we're in. And that's, of course, they tell us. Let's take a look at the sine ratio here. Sine is y over r, and sine is negative in which quadrants? Well, let's see where it's positive. It's positive here and here because it's sine. So it means it's negative in the other spots. Here's my 2 quadrants. There's my right triangles. My y values are negative root 3s. My r values are 2s. I know root 3 is always across from pi over 3. So what are my answers? My answers are, well, theta is, now think about this. This is the angle I want to measure from 0 all the way around over here. So it's more than pi. It's pi plus pi over 3. Or in other words, 4 pi over 3. If you think of this, this is a third, another third, and the third third. So my answers are pi over 3, or sorry, 4 pi over 3, and the next one would be 5 pi over 3. Right? If this is a third, then this is a third, and then that's the third third. Now try the next one. Secant equals 2. Okay, secant is related to cos. Cos is positive in the C and the A. Secant, well, cos is x over r, so this is r over x. So I got an r value of 1, sorry, an x value of 1, an r value of 2. I need a 1, a 2, and a root 3 in here. Across from root 3 is always pi over 3. What are my answers? Well, one of them, the first one, just up to there, is just pi over 3. And the second one goes all the way around to here. It's not quite to the end. It's a pi over 3 short of the end. So it's 5 pi over 3. Because 6 pi over 3 would be 2 pi, right, all the way around. Now, if you can't do that in your head yet, just like this. Okay, 2 pi is all the way around, and I stopped a pi over 3 before that. Okay, 2 more to try. Let's see if we can do these ones. I got tan theta is 1. Where is tan positive? Well, it's positive in the T and the A. Tix, y over x, so 1 over 1, 1 over 1, but we know they're both negatives, so it's left and down. This is a 1, 1, root 2 triangle, which makes these pi over 4s. So my answers are pi over 4, the first quadrant one, that's this one. And the next one I've gone past pi by another pi over 4. If I think about what's 1 plus a quarter, that's 5 pi over 4. That's that one. A quarter more. And then I got a decimal one. What do I do with decimal ones? Well, Decimal ones, I'm going to need to use my calculator. But I can't do cosecant on my calculator. So I need to think about what is this related to. Cosecant is the reciprocal of sine. In other words, it's flipped over. That's what that is. I'm going to need my calculator to do this because I don't have a special triangle that has a 3.2 in it. Be careful that my calculator is still set in radians though, because we're talking about radians here. If we do that, we get 0.318 rad. Now that's one of the answers, but again, there's always two answers, A and S. The answer I found is that one right there. So one of my answers is, of course, 0.318. But the other one, theta number 2, is this amount. Well, that amount is pi minus this. Now pi, because I'm using decimals, has to be my decimal version of pi, 3.14. So I put that in my calculator. I get 2.82 radians. Okay. So decimal one's no different. Just make sure you have your two answers. Okay, so you need your diagram, your cast rule to figure that out. Whenever you do a calculator question, make sure your calculator's in radians in this unit because we're talking about radians. And then just think about the relationship between pi or 2 pi. Right? Pi is here, 2 pi is here. Am I before it or am I after it, and by how much? All right, last little thing, a little application. A word problem for us. Ray is flying his kite at the end of a 50-meter string. Due to the wind, the string makes an angle of pi over 6 with the ground. So if we have Ray on the ground here and the kite's up here, we can make a triangle. Okay, the string is 50 meters long. The angle with the ground is pi over 6. How high is the kite? That's x. Okay, so we can do old stuff like SOHCAHTOA, which is what this question is, but using radians. How are we going to do that? Well, let's see what we got here. We got our opposite and our hypotenuse. It tells me to use sine of the angle equals my opposite over my hypotenuse. We can cross multiply, so we'll get 50 sine pi over 6. And type that into our calculator, and hopefully you guys got 25 meters. If you didn't, odds are your calculator is not in radians still. We need it in radians all the time for this stuff. That's what we're dealing with. Okay, the wind changes directions. The string now makes an angle of pi over 3. How has the height changed? Well, if we turn this into a pi over 3, but same picture, different problem, we'll do the same math, right? X will still be 50, but now it's going to be the sine of pi over 3. We get an answer of 43.3. Okay, how has the height changed? Well, the height has increased. It went from 25 to 43.3, so 18.3 meters. Okay, so radians aren't any different than dealing with degrees. We just have to think about the different values being used. The processes have stayed the same. Okay, a couple questions to try tonight. Measures of angles. So working forward, working backwards. Give them a try. If you're stuck, come see me.